All right, y'all. This is part 2 of we're looking at quadratic functions. So in part 2, we're going to be talking about something called completing the square. So let's look at it. So we have this polynomial form we know is f of x equals ax squared plus bx plus c. If you're curious, I am just reading off of here. It is the most useful form for finding the y-intercept. So here's something that's pretty cool to come to realize, is that if we said the y-intercept is when x is 0. So it's always, and this is an important idea, anytime it's the intercept, the other letter is equal to 0. So the x value would be 0. And what would happen here is if you substitute both, if all the x's were 0, you'd have a 0 squared plus b times 0 plus c would give you y, which means y would become c. In other words, the constant, or the value always by itself, is the y-intercept. So c would be the y-intercept. Okay. The x-intercepts are the solutions to ax squared plus bx plus c equal to 0. I'm reading them off of here. And so keep in mind that there's a couple ways of solving that, which is you could either solve it by factoring. You could also plug into the quadratic formula, which is negative b plus or minus square root b squared minus 4ac all over 2a. And then the last point was that to find the vertex, we use x equals negative b over 2a. So one thing that I think that is commonly overlooked, I'll put this a little more down here, is that when we look at, let's say our parabola does something like this, okay, the zeros are negative b minus square root b squared minus 4ac over 2a, and this one's going to be negative b plus square root b squared minus 4ac all over 2a. And we know that this one is going to be negative and this one is going to be positive right here, because obviously if you subtract, it's going to be a smaller value than if you add. Okay. The vertex, because of the axis of symmetry, the vertex is in the middle. So if we took negative b minus square root b squared minus 4ac over 2a, and you added negative b plus square root b squared minus 4ac all over 2a, and then divided by 2, you'd actually would be finding the average. And the reason why I'm mentioning this is that the average of these 2 points would be the vertex. That's how you find the middle. You average them. And so if we average these, what's interesting about it is because the denominators are the same, this is a minus and this is a plus, these will cancel out. So the square roots cancel out. So you're left with negative 2b, because you have negative b here, plus another negative b here. So it's going to be negative 2b over 2a all over 2. The 2's here and here will cancel out. So you're left with negative b over a all over 2, which is the same thing as, you guessed it, negative b over 2a, which is what it's saying is the x value. Now this is just a fancy way of saying that once you get the x value, substitute it back in and you find the y value, which would be your k. But yeah, so what's equally as nice is if you have the quadratic formula memorized, notice that negative b over 2a is the first part of it. So the vertex form is just the first part of the quadratic formula. So if you have the quadratic formula memorized, you have negative b over 2a memorized. Okay, so for the function x squared plus 4x minus 5, find the vertex and the x and the y-intercepts, then sketch. Okay, so what I'm going to do is I'm actually going to start off with the easiest one, which is the y-intercept. That's just negative 5. As we recall from earlier, I said that c represents the y-intercept. So we know this thing, the y-intercept is going to be 0, comma, -5. Okay. So the next thing is, what is the x-intercept? Well, the x-intercept is when y is 0. So what would that be? Well, 0 equals x squared plus 4x minus 5. I'm going to factor this. This is just going to be plus 5 minus 1. And if you've forgotten how to do this, it's pretty straightforward. All I'm doing here is I'm asking myself what times what gives me -5. And if I add or subtract these, if I add 5 plus -1, do I get to 4? That's all I'm doing here. So this is equal to 0, which then means that x is equal to -5 and x is equal to 1. So the x-intercepts here will be -5, comma 0, and then 1, comma 0. And I have two things that I can do to find the vertex. I mean, I can obviously go straight to the formula, which is -b over 2a, right? Or look what I said earlier. I said it was the average, right? This is just saying the average of my intercepts, my x-intercepts, right? So if that's the case, if I want to, I can add -5 plus 1 divided by 2. So I could just say -5 plus 1 divided by 2, which I think is the easiest way. And this will give me -2. So I know my x value is -2. However, just to follow according to what has been given here, notice that A is 1, B is 4, and C equals -5. So -b would be -4, 2a is 1. Oh wow, we still get -2. So if you prefer just using the formula, you can. To find the y component, the k value of the, based off the equation, we would just substitute in -2. So this is getting a little, I'm going to plug it in this corner here. And so this is going to be, remember, x is -2. So I'm going to use this format. You can use the bottom format if you want to. Okay, but I'm going to use the top. So this is going to be -2 squared plus 4 times -2 minus 5. So this is going to be 4 minus 8 minus 5, which is going to give me 4 minus 8 is -4, minus 5 is -9. So now I know the y value is -9. So this tells me that, I'm going to squeeze it in here, the vertex is going to be, what did I say x was? X was -2. And we just calculated y to be -9. So we have -2, -9. Is that right? And so if I graph, then graphing is very easy. The y-intercept is 0, -5, so it's going to be 1, 2, 3, 4, 5. Wait, is that right? 1, 2, 3, 4, 5. Make a thick point, that point there. We said the x-intercepts are -5, so that's going to be 1, 2, 3, 4, 5. We also said 1, which would be here. We said the y-intercept is -2 and then 9. Let's see how far this goes out. 1, 2, 3, 4, 5, 7, 8. So 9 is going to be, it's going to be just off the grid. So it's going to be -2, 9, do something like right there. Let's say it's right there. And so if we draw a sketch, it's going like so. That's pretty much it. So easy enough, not too bad. Multiple plans of attack. Let's move on. Okay, so the x-intercept is, the x-intercept form is actually what I did right here. I know I got a lot of math going on here. But this format, this basically gets you where it crosses the x-axis, and hence it's the most useful for finding the x-coordinates. Okay. in this form, the x-intercepts are the solution to f of x equals 0. Again, it's fitting exactly with what I did here. The y-intercept, we said, well, the y-intercept is when you make x equal to 0. So what's interesting here is that it does formulate into AST, which means you take the number in front times whatever s is and whatever t is, and that will get you the y-intercept. But all you need to remember is that you need to just plug in x as 0 and you'll find it. And this is just telling you what I said earlier, that if you average, right, if you average out your x-intercepts, you do get the vertex, which is what I did here. So it's actually just rehashing what we've talked about before. What is the best way of doing this? Whatever pops into your head is the best way. So let's handle number 6. So again, we know that the since this is an x-intercept form, we automatically, I'm just going to go jump straight to it. We know the x-intercept is 3. This is when x equals 3 and x equals -1. So we know that it's going to be 3, 0 and -1, 0. So if you're confused with what I'm saying that if I plug in 3 here, y will become 0. And if I plug in -1 here, y will become 0. So we know we have -1, 0. And then we also have 3, 0. So if I do 3 plus -1 divided by 2, if I average them out, right, that would give me the middle point, which is 1. So I know that in between -3 and -1 is 1. And that's going to be where my vertex lives. So if I want to figure out the y value, then I'm just going to plug back in. So notice what I'm doing here. I'm literally just substituting back in 1 and for the x values. So if I solve this, I get -2 times -2 times 2. Y is 8. So the vertex lives at 1, 8. Which, let's see here, that'd be 1, and we have 8 is going to go up. So 1, 2, 3, 4, 5, 6, 7, 8. So this will be at 1, 8. Right? And now the last thing that I need to do is I need to figure out the y-intercept. And to y-intercept, I'm going to just do it over here. Again, we said the y-intercept is when x is 0. So y is going to equal to -2, 0 minus 3, 0 plus 1, which is going to be y equals -2 times -3 times 1. And some of you might be saying, well, Mr. Anderson, why did you do that? We said over here it's AST, so you just have to multiply the number in front times these values. So you could have just said -2 times 3 times 1, and you could do that if you wanted to. I like the idea of what it is better. So I like the idea of saying the y-intercept is when x is 0. I like to understand, and I think that is better than memorizing formulas fundamentally, so that's why I'm always going to go back to that. I am going to rewrite this, though, as 0, 6. So let's see here, where's 0, 6? 1, 2, 3, 4, 5, 6. And so we can, it makes sense for it to do that, right? Looks pretty good. And there you go. And this is the y-intercept. And there's our answer. So hopefully that makes sense. And let's move on. Okay. So the next one is example 7. So in 7, it says write the following functions in polynomial and x-intercept form if possible. So polynomial form is when it's written all out. So we'll start with the first one, which is a is f of x equals 2 times x minus 1 squared minus 8. So we're going to expand this out. So if I expand this out, this is going to be 2 times x minus 1 times x minus 1. And if you're thinking to yourself, well, I want to distribute first, the reason why we don't distribute first is PEMDAS, which is we have to do exponents before we multiply. So this is going to look like so. So now we're going to multiply. The order is up to you, but I like to go ahead and FOIL this out. This is going to become x squared minus 2x plus 2, which if the leading coefficients are both 1, you essentially are just adding these two. So -1 plus -1 is -2. And then you multiply these. So -1, I wrote I wrote 2, but I really should have written 1. That's funny. -1 times -1 is 1, obviously. Okay. So we have that. The rest of it is the same. Okay. Next up, I'm going to distribute. This is going to give me 2x squared minus 4x plus 2 minus 8. And then I'll finish it off by cleaning it up. So 2x squared minus 4x minus 6. And this is in polynomial form. So it does say f of x. So we'll go ahead and we'll call it f of x equals 2x squared minus 4x minus 6. Okay. Then it says in x-intercept form. So this is going to be interesting because everybody does this a little differently. Okay. What I'm going to do is first I'm going to look at it and ask myself, can I factor something out of it? So if I look at it, we can see that all of these are divisible by 2. So we'll factor out a 2. So this gives me x squared minus 2x minus 3, which makes this very easy to factor. So when I factor it out, again, all I'm saying is what times what is 3, which is 1 and 3. And if I add and subtract, I have to get to -2, which would be negative and plus. Obviously in the front it's x and x. So there it is. So again, this part right here, this is polynomial form. And this right here is, what do they call it? X-intercept form? I think that's the exact verbiage here. X-intercept form, yeah. Okay. And it looks like I'm a little bit out of space here, so I'm going to go ahead and do this. I'm just going to jump to, and let's go ahead and do B here. Okay. So B is g of x equals 3x squared minus 6x plus 6. And so the first one is state in polynomial form. Well, it's given in polynomial form, so we don't have to do anything there. This is already in polynomial form. Okay, then the next part is to factor it. So when I'm going to factor it, I'm going to first factor out a 3 out of everything, because everything has a 3 that can be factored out, just to make my life easier. And now we have a problem, because the factors of 2 are 2 and 1, and if you add them together, you get 3. And if you subtract them, you always get 1. So there's no way I'm going to get a -2 out of those factors. So it does not factor cleanly. So we do not have to, there's no x-intercept form. You could find the x-intercepts by doing the quadratic formula. But what you'll notice, so remember the quadratic formula is -b plus or minus square root b squared minus 4ac all over 2a. If I plug in there, I'm going to get -6 plus or minus square root -6 squared minus 4, 3, c is 6 all over 2a, which is 3. So if I clean this, I get 6 plus or minus 36 minus, now this is going to be 12 times 6, which is 72 all over 6. And I can keep going, but this right here illustrates to me that I'm going to get a negative. And so what that means is if you get a negative, it means that however, whatever the parabola looks like, it's not going, you're getting an imaginary solution here. When you get an imaginary solution inside, this is called the discriminant. When you get an imaginary solution inside the discriminant, that means that it's not touching the x-axis. So there is no x-intercept form. And so B was actually really easy. Here I was choosing a new page, and yet with B I did not even need a new page because it was just written there. So let's see how much we have to flex for the last one, h of x. So h of x is nice in one sense. H of x is written already. This is an x-intercept form. So all I need to do is factor it out to get it into polynomial form. So this is going to become x squared plus 2x minus 8. Again, 4 minus 2 is 2. And then 4 times negative 2 is negative 8. It's kind of a nice shortcut to that, so you don't have to worry too much about it. And then we will factor this out. So that means we're going to just distribute the negative 2 into everything. Make negative 2x squared minus 4x plus 16. And this is in polynomial form. And there we have it. So hopefully that makes sense. Now comes the interesting part. And the interesting part here is we have to, it says to convert a quadratic function to transformation form. So transformation form is a fancy way of saying vertex form. It may be necessary to complete the square. So how do you complete the square? So the first thing that's very important when you complete the square is the leading coefficient has to be 1. So that where it says x squared, that is actually saying 1x squared, and that has to be the case. And so what you do is you just want the x terms by themselves. So notice here you just have the x terms by themselves. So what that means is I actually subtracted 7 over here, right? And so what we're going to do is you're going to take this 8, and to complete the square, you take the 8, which is the b value, you're going to divide by 2, and then you square it. So you're going to take 8, you're going to divide by 2, and then you're going to square it. Now, what we're actually doing is what you do to one side of the equation, you have to do to the other. So we get such, and this is 8 divided by 2 is 4, 4 squared is 16. So this is where we're getting 16 and 16. Okay, now what we do is negative 7 and 16 gives me 9. 16 minus 7 is 9. And the reason we do this is that this right here becomes x plus 4 quantity squared. By completing the square, we create that effect. And so what we're doing here again, how do you get 8 or how do you get the 4? Well, a very quick, easy way of getting the 4 is this inside portion, and this is always true, the 8 over 2, that is that 4. Okay? And the last step is that we subtract the 9 to the other side. So this becomes, let's just do another example. I think it makes more sense. So let's do this one here. So again, the leading coefficient has to be 1, which is the case. Okay. We're going to move the 4 to the other side. So we're going to have x squared minus 6x. So you want all your x's together. And then we're just going to do it. So we're going to divide by 2 and square. So we're going to take the negative 6, we're going to divide by 2, and then we're going to square. And notice what you do to one side of the equation, you have to do to the other. So that means I'm going to have to add a negative 6 over 2 squared to the other side. Okay, and we'll clean it up. So this is going to give me f of x minus 4. So what's negative 6 divided by 2 is negative 3. Negative 3 squared is 9. It's going to equal x squared minus 6x plus 9. And this will clean up to f of x plus 5. Remember the whole point of this, right? The whole point of this is that it's just this part here, which is this number divided by 2. So it becomes x, well, what's negative 6 divided by 2? Negative 3 squared. And if you don't believe me, FOIL out x minus 3 squared, and you'll see you'll get back to x squared minus 6x plus 9. And then to finish it off, we're just going to subtract 5 from both sides. And so f of x equals x minus 3 squared minus 5. And there's my answer. So hopefully that makes sense. Let's do one more. So here, so there's a couple ways of doing this. The quick way of doing this is just to say, well, if I know that the intercepts are 5 and negative 1, right? Then we can add 5 plus negative 1 and just divide by 2, which gives me 4 over 2, which is 2, which means the x value is going to be 2. So in the vertex form, I now know the x value is 2. So, well, how do you find the y value? Well, just plug it back in. So you have 2 x, but we don't have x anymore, so we have 2 times the x value, which is 2 minus 5 times 2 plus 1. And we can just solve this. So this is 2 times negative 3 times 3, which is going to give me negative 18. And so we know the vertex is 2, negative 18. This is still the a value, so the format, if it's ax minus h squared plus k, well, we know it's going to be y equals 2x minus 2 squared plus negative 18, which is how I like to write it because it emphasizes that plus k effect. But you can also rewrite it as y equals 2x minus 2 squared minus 18, and that would be legit as well. So that would be the easiest way to do it, and you wouldn't have to complete the square. So hopefully that makes sense, and y'all are cool with this, but let me know if you need more examples or whatever, and we'll definitely do them. All right, guys, see y'all in the next video.